Today we get to make our lives easier. We get to learn some rules for differentiation. You've went through the hard way of doing this using the definition of derivative. Now let's kind of start condensing a little bit. We talked about, I'm just going to start with this one, the function x squared. Okay? And we talked about the relationship between the graph of the function and the graph of its derivative. Okay? We said that all of the slopes of the tangent line when x is greater than 0 are positive. We said that all the slopes of the tangent line when x is negative, all of those slopes are negative. And you did the definition of derivative, and you found out that that corresponded to a slope function of 2x, which is nothing more than a linear. And we've talked about the relationship between the original function and its derivative, which we call, don't forget, we call this the general slope function. This is the function, 2x, that will tell me the slope of the tangent line to the original. And we matched up these values. These are positive slopes, so if I look over here, all of these are positive. And we said all of these are negative, so lo and behold, all of these slopes are negative. And we talked about the fact that I can use the slope function if I wanted to know specifically the slope of the tangent line when x is 3. I come up to this tangent line and I want to know what its slope is. Well, I can use the derivative, and I can do f prime of 3, which we know is 2 times 3, which is 6. So over here, the value of this is 6. Okay? That corresponds to the slope of this tangent line. Okay? So we've done all of those relationship and theoretical things. Now let's get to some of these shortcuts. You found out that the derivative of x squared was 2x. Okay? And that is going to lead us into the power rule. All right? But we also learned some other ones. And I want to kind of start at the bottom and work our way up. Let's start with the derivative of a constant. What did we learn? If my original function was 12, what did we learn the derivative of that is? The derivative, okay, up here is 12 someplace. What's the slope of that? Everywhere? 0. We found out that the derivative is 0. So here's how we're going to write these rules. I'm going to put d dx of c. What does that mean? The derivative of a constant c is equal to 0. There's my first rule. The derivative of any constant is 0, automatically, because the slope of the tangent line is going to be 0. If f of x equals 31, then f prime of x is 0. Boom, automatically. The derivative of any constant is 0. Okay? Then we also learned about linears. You know, a linear function like mx plus b. Well, what would the derivative of that be? Like if I had, what did we learn about that? If f of x equals 3x minus 7, what would the derivative of that be? What did we learn? 3, right? Because the slope of that tangent line would lay right on top of the linear function. So guess what our rule is? The derivative of any, we could just say Cx, right? Or I could say mx plus b. Whatever you want to say is just going to be c. Okay? If x is to the power of 1, if it is a linear, the derivative is just the constant in front of it. So for example, if I wanted to find the derivative of 7x, it's going to be 7. Okay? Okay, let's get to the big one that we're going to learn today. And you've already discovered this one too, the power rule. The power rule says that the derivative of x to the n is equal to n times x to the n minus 1. You just bring the power around and you multiply it by what is in front of it. So, we learned that if my function is x squared, then its derivative, I just bring this power around, 2 times x, and what is 2 minus 1? 1. So the derivative is 2x. Okay? So for just a couple quick examples here, if my function was x to the 5th, then all I have to do is bring the derivative, the general slope function, would be 5x to the 4th. You bring the 5 around, take 1 off the power. Okay? What if if my original function was 3x cubed? Then using the power rule, what I have to do when I bring this 3 around, I have to multiply it by this original 3. So it will become 3 times 3 x to the 2nd, or 9x to the 2nd. And that's how that power rule works there. But don't forget about fractions. Let me do one more. What if my function was 6x to the 5/2? Well, when I bring my power around, okay, the derivative of this will be 5/2 times 6, which I will put over 1, x to the 5/2 minus 1. Well, how can I subtract 1 from 5/2? 2/2. Okay? So now I need to clean this up a little bit, do my factoring, get out my slasher. So this will become 15x, 5/2 minus 2/2 is 3/2. 15, the derivative, the general slope function, would be 15x to the 3/2 using the power rule. Definitely shorter than the definition of derivative, I would say. Now, the next one is also important. It is what is called the constant multiple rule. And oh my goodness, this is so big, but for some reason it seems like calculus students always forget this. The derivative of c times any function. C is a constant. Okay, so if c is a constant, the derivative of a constant times a function is equal to very important, the constant times the derivative of the function. And we've actually already used this a second ago. Didn't we just use this rule right here? Wasn't there a constant in front of the function? The 3? Right? So it got multiplied by the derivative. So let's just kind of talk our way slowly through this. If my function was 7x to the 5th, the constant multiple rule says that technically what I'm doing is finding the derivative of x to the 5th and then multiplying it by 7. So when you bring this 5 around, I know that we're going to go ahead and do 5 times 7. But you need to understand that this 7 is technically getting multiplied by 5x to the 4th. Constants just come along for the ride, okay, if there is a constant times a function. So this derivative would be 35x to the 4th. You know, another classic example of this, we're not going to do the derivatives of trig functions today, even though you already know what some of them are with our exploration we've done the last few days. We'll call this example 1. Just real quick, what if my derivative was 5 sine of x? No, I'm sorry, what if my function was 5 sine of x? Excuse me. Now what did we learn? The derivative of sine is cosine. This rule says that the derivative would be 5 cosine of x. The 5 comes along for the ride. It gets multiplied by whatever my derivative is. Very, very important rule with those constants. Okay, some other ones that are more common sense. Sum difference rule. Okay? It's more common sense. I don't want to spend a bunch of time on it. It says that if I take the derivative of two functions added or subtracted together, all right, if I do the derivative of two functions added or subtracted together, I can just do the derivative of each one separately. So I can do the derivative of f of x plus or minus the derivative of g of x. There might be 5 things added together. Who knows? But I can just do each one individually if they are added or subtracted together. Like, we're not going to work through all this one, but let's say I've got a good old-fashioned polynomial like negative 4x to the 5th minus 3x cubed plus 2x squared plus 7. Maybe we'll just go ahead and do the derivative of this anyway. Do us some good. So what would the derivative of this thing be? Well, what we're going to do is we're going to do each piece on its own. So let's look at the first one. Well, the derivative of x to the 5th is 5x to the 4th. Well, what's 5 times negative 4? Negative 20x to the 4th will be the derivative of that first term. Now we're going to do the derivative of the next term, which will be, using the power rule, negative 9x squared. And then we're going to do the derivative of the next term, plus 4x. And then we're going to do the derivative of 7, which is what? 0. So I don't even need to write plus 0. Okay? Now, another important rule, and this one I don't think you saw in your exploration yet. The product rule. You will use this one so many times that you will have it memorized. Promise you. All of these rules you will. If I want to do the derivative of one function times another function, the product rule says that it is the derivative of the first function, which I'll put in blue, the derivative of the first function times just the second function the way it is. I'll put it in red. Notice we're only doing the derivative of the first function. The derivative of the first function times the second one the way it is, plus, if I had more room, I'd just keep going there. The derivative, on your notes, just keep writing it all straight out, plus the derivative of the second function times the first function the way it is. When you get good at this, the way that I remember it is the derivative of the first times the second plus the derivative of the second times the first. Okay? So I think derivative of first times the second plus derivative of the second times the first. That's kind of the way that I think through it in my mind as the rule. Okay? So, if I add two functions multiplied together, let's do one of these examples using this rule. If I had the function x squared plus 1 times x cubed plus 3. Anytime I am doing the derivative of a product of functions, I must use the product rule. I have to. It's not optional. You can't take the easy way out. Okay? So if I want to do the derivative, f prime of x will be the derivative of the first function, whatever that is, we'll figure that out in a second, times the second function just the way it is, plus the derivative of the second function, x cubed plus 3, I'm supposed to say x cubed plus 3, times the first function the way it is, x squared plus 1. Okay? That's how the product rule operates. Now let's figure out what these derivatives are. What is the derivative of x squared plus 1? The derivative of x squared would be 2x, right? What's the derivative of 1? 0. So we just have 2x. And that is going to be multiplied by x cubed plus 3. Plus, what's the derivative of x cubed plus 3? Well, that's going to be 3x squared. Good job. Times the second, back to the first function the way it is, the x squared plus 1. All right? So remember, you're only doing derivatives of certain things. Now you just do distributive property and finish it up. Okay? So I would do distributive property, 2x to the 4th plus 6x plus 3x to the 4th plus 3x squared, combine my like terms, and so on. 5x to the 4th plus 3x squared plus 6x. That would be my derivative. Now, if there's a product rule, don't you think there's a quotient rule? Yep, there is. We need to get that in today, too. And yes, you will get plenty of practice on using all of these rules. The quotient rule, here's what it says. If I have the derivative of f of x divided by g of x, the derivative of a quotient of functions, I do the derivative of the top times the bottom the way it is, minus the derivative of the bottom times the top the way it is, all over the bottom function squared the way it is. Okay, you have to pay attention to where the derivatives are. Okay? The only places where there's a derivative is right here and right there. Okay? So, if I wanted to do the derivative of a rational function, let's just do it right here. Let's say that I had x squared minus 1 over x squared plus 1. And I wanted to do the derivative of that quotient. Well, using this rule that I just wrote down, I would do the derivative of the top, which is 2x, times the bottom the way it is, x squared plus 1, minus the derivative of the bottom, which also happens to be 2x, times the top the way it is, x squared minus 1, all over the bottom function squared the way it is. And no, that's not x to the fourth plus 1. You have to do FOIL, or do the square of a binomial shortcut. So then, to finish this up, you would do distributive property and simplify this thing, what? 2x cubed plus 2x minus 2x cubed plus 2x all over x squared plus 2x squared, I'm sorry, x to the fourth, should be x to the fourth, plus 2x squared plus 1. And then, of course, my 2x cubes go away, and it looks like I've got 4x over x to the fourth plus 2x squared plus 1. Okay? And I think that bottom would actually factor if I wanted to. Okay? And we will stop there for today. We have some more rules that we need to review, though. Okay? So we're going to stop for day 1.